This is Herb Coster with an Apparatus News feature story. A report on General Electric's research and development. On a former country estate just outside of Schenectady and overlooking the Mohawk River are new handsome structures that house the General Electric Research Laboratory. This first industrially sponsored laboratory was established in 1900, in the days of Thomas Edison and Edwin Rice. Other well-known and remembered names fill the roster of early pioneers. Charles P. Steinmetz, mathematical genius of the electrical industry and one of the early promoters of the General Electric Research Laboratory. Dr. Willis R. Whitney, the research laboratory's first director, who served in this capacity until 1932. Dr. William D. Coolidge, best known for his work in X-rays, and second director of the laboratory. Dr. Irving Langmuir, Nobel Prize winner, who explored a great variety of fields and was associate director of the laboratory from 1932 to 1950. Dr. Saul Dushman, who engaged in a long series of researches in high vacuum. Dr. Albert W. Hull, an inventor of many types of vacuum tubes. And there are many others. Today, scientific investigation continues. For in the words of President Cordner, future growth, profitability, and security for General Electric are closely linked to maintaining a high level of research and development to sustain continuous product innovations and improvements. Investigation takes place in many fields. For example, in modern metallurgy, fundamental research is carried out employing the techniques of chemistry and physics. New metals, alloys, and ceramics are emerging for practical application. For many years, General Electric has pioneered in the development of new types of electron tubes. Out of this work and investigation have come products such as micro-miniature tubes. One of the most advanced frontiers of science today is the study of atomic energy for peacetime use. To more fully understand the subject, scientists probe the atomic nucleus to get at the fundamental nature of matter. A synchrotron, or atom smasher, can accelerate electrons to speeds close to that of light. Not even small molecules escape the investigation of the scientist. Today he can trace their patterns and modify molecules to fit his needs. Research moves forward, but unless the findings can be applied, results remain academic. In 1955, an important development was made public. The exact date was February 15th. All major means of communication carried the story.
And here's an item just released before broadcast time. Scientists of the General Electric Company announced today that they have developed man-made diamonds. This is a climax to man's 125-year effort to duplicate nature's hardest and most glamorous substance.
Man-made diamonds. The crystals are not imitation. They're the same as the diamonds taken from mines of the Belgian Congo and Brazil. Research has enabled us to make products of real value from materials that were formerly valueless. Commenting on this scientific research is Dr. Guy Suits, Vice President and Director of Research of the General Electric Company.
I have here on my desk two very interesting objects. A small bottle of material worth $1,000 and a small silvery ingot that is more valuable than an equivalent amount of gold. The bottle contains industrial diamonds, but not diamonds dug from the earth. These diamonds were made by man, and an important point is that the raw material from which they were made costs less than a penny. And this silvery ingot is not silver but silicon, the most abundant solid element on the earth. Now, the practical value of these industrial diamonds is that with them we may machine our strongest metals and alloys and glasses and ceramics. The practical value in this silicon ingot is that from it we may make at least 5,000 transistors. Both of these materials symbolize modern scientific alchemy, alchemy that is literally creating an industrial technological revolution in America. Primitive man dug raw materials from the earth and used them as is or with little modification. Now, an easy measure of technological progress is the extent to which industry gives added value to basic raw materials. Think, for example, what the art of steelmaking adds to the value of iron, and what this added value has meant to technological progress over the last half-century. Making diamonds and electronic devices from the simplest of materials typifies the ability of modern science to add value to basic raw materials.
Thank you, Dr. Suits. After a research project is accomplished, in this case man-made diamonds, ways must be found to apply the results of this research. For more of this story, we switch to General Electric in Detroit.
I have Kenneth R. Beardsly, General Manager of the Metallurgical Products Department. Mr. Beardsly, I believe you have some important news.
Indeed, we have. Man-made industrial diamonds, equal in performance to those produced by nature, are out of the research laboratory stage and are going to industry in substantial quantity. By the end of this year, tens of thousands of carats of these man-made diamonds will be in industrial use for grinding wheels, for sharpening cemented carbide tools, lapping compounds, and similar applications. The customary time for bringing a scientific project from the laboratory to commercial realization is 5 to 10 years. In this case, we have accomplished it in 2 years. The project is a success. We have proved to ourselves that the manufacture of man-made diamonds is commercially feasible, and we now have plans for an expansion of our diamond production in 1958.
Thank you, Mr. Beardsly. And now I have Mr. John D. Kennedy, Manager of the Diamond Section. Perhaps you can tell us something about the industrial acceptance of man-made diamonds.
Industry in general has been extremely interested in our program. We have approached those areas of application in field test which offer the greatest immediate potential.
Thank you, Mr. Kennedy. The Metallurgical Products Department is formerly the Carbaloy Department, and their diamond pilot plant is in operation now, and full operation is expected by the end of the year.
From research to practical application, man-made diamonds are only one example of many new products that are being manufactured today. The General Electric Company now operates 47 full-scale laboratories, and in other locations it has great quantities of laboratory equipment, computers, and instruments. In all of these places, research results in practical application. You have more and better products because somewhere a research man sought a better answer or searched for a better way.